Okay, here we have a question that's been submitted by a student, and so I thought it was absolutely worthwhile going over. Actually, I've had a couple of students asking about this problem. This one says, name the rational numbers from the list below. And I think that the problem is that my explanation of a rational number from our class discussion was a little bit incomplete. So we probably want to go back over that again. Okay, a rational number. These are a ratio of two integers. Now, this is what we talked about in class when we talked about this. So we said that, a ratio of two integers would be something like, 5 over 6. So basically, another way of looking at it is anything that can be written as a fraction is a rational number. Now, where this gets to be a little bit dicey is when we're talking about decimals. So rational numbers include terminating decimals. Now, whenever I say that, I mean things like 0.5 or something like 0.34, something like that. These would be considered rational numbers because they can be written as fractions. 0.5 would be 1/2. That's its fractional equivalent. 0.34 would be like saying 34 hundredths, which could then be reduced down. So they actually have a fractional equivalent. It would also be repeating decimals. And when I say repeating decimals, I mean things like 0.3333333, on and on and on. Now, usually you will see these written as zero point 0.3 with a bar over it, meaning that it's the same constantly. All the way through. This is technically a rational number because it actually has a fractional equivalent. This would be 1/3. 1/3 is 0.3 repeating. Okay, so let's look up here at this list that we have. We have these numbers, -3. Well, this is a rational number because it is an integer, and all integers are rational numbers. In fact, we could write -3 as a fraction if we put it over 1. So that maybe could help us see that better. 0 is a rational number. We could write, again, that over 1. Any kind of what we think of as being whole numbers. It's not the technical term, not proper for -3 anyway. It's not a whole number, it's an integer. But anytime you have a plain old number, no decimal, no fraction, nothing like that, you can write it over 1, and so you can see the fractional form. So 11, again, would be a rational number because we could, again, write 11 over 1. 3.44 is a rational number because it is a terminating decimal. 3.44 can be written as 3 and 44 hundredths. Now, the 44 hundredths part can be reduced down, but because it can be written as a fraction, that makes it rational. The square root of 5 is not a rational number. Remember, square root is the opposite of squaring. So you cannot square something and get 5 easily. So that means, therefore, you can't go backwards and get something nice. And if you were to do square root of 5 on your calculator, you're going to get some number that goes on and on forever. It has no rhyme or reason to it. It doesn't repeat. It doesn't do anything. So this is not rational. The square root of 4 is the other one in this list that might be tricky. The square root of 4 is actually a rational number because if we think about it, let's go backwards. What do we square to get 4? Well, that would have to be 2. So therefore, the square root of 4 is actually 2. Square rooting is going backwards from squaring. And because the square root of 4 is 2, which can be written as 2 over 1, it has a fractional equivalent, so it is a rational number. Now, the next two are rational. They look rational, so they look like fractions. But the last one here, this may look like a repeating decimal, but it is not. It repeats, yes, but not in a specific pattern. In order for this to be a truly repeating decimal, it would have to be 3939393939. It has to be repeating in the same